Let's do some computer janitor things. I am exploring low VRAM scenarios for inferencing, specifically image generation today. So I have a 5070 laptop GPU here that only has 8 gigabytes of RAM, and everything's being powered through integrated Radeon card for the UI and stuff. So I want to be able to see what type of image generation we can do with ComfyUI and learn how to do some image editing through it. Then eventually I want to explore how we can programmatically run quantized image generation or image editing models through Python. So let's just start out slow. The only experience I really truly have with ComfyUI is with my DJX Spark. So this is going to be like one of the instances where I'm going to set it up from scratch on another computer that's not the DJX Spark. This is Fedora Linux, and I think the ComfyUI exe really only does either Windows or Mac. In this case, what I want to do is install ComfyUI from GitHub. And I think all that is that it just involves cloning the repo. So I'll clone the repo somewhere, I guess, in code. Maybe, cd code. I'll probably make a repos directory if I already don't have one. And I can just go there and git clone ComfyUI. And already I know that I'm going to have to create a virtual environment under there. Been around this once already. So yeah, so we have all these files here, which should mirror that of the repo. Yeah, so I like to create virtual environments inside the repo itself because it's easier to organize. I don't have many other virtual environments all over the place. I know some people like to create virtual environments in one specific directory and activate them for specific repos that they want to work in. For me, it's just easier to manage in my head or just doing it per repo instead. So yeah, it's all preference. So I'll start by creating a virtual environment by executing python 3-m venv, and I'll create my virtual environment in a .venv folder. And I'll just source venv bin activate. And now I have my virtual environment activated inside the ComfyUI repo. And all it is, going by the directions here, I think it just involves, see here, here, manual install. I have an NVIDIA GPU, so it's just installing PyTorch CUDA 13, which I already have. And then we will, let's see, just install the requirements.txt. Let me just zoom in a little bit more. So we're going to install PyTorch and then install the requirements.txt. Go from there. Okay, so PyTorch, inside the virtual environment, we're going to grab the CUDA 13 version. And that's going to take a while. I guess I can just cut the video to when it's done. Okay, now that Torch is installed, it's just installing the requirements.txt. So requirements.txt. And that may take a while too. So I will cut the video. Okay, so next step, I think that's it. I think we can just run the main.py. There should be right here. There should be documentation. It's as easy as Python main.py, but I think we want to listen on all interfaces and a custom port. So that's easy. That's as simple as Python main.py -- host 0.0.0.0 port. Now, I'm going to choose 8888, but how do I actually find what to put here? Like what arguments to put into main.py to listen on all interfaces and all ports? Well, most command line programs still expose a help menu. And in this case, if I use python main.py -- help here, I get the documentation, and I guess it wasn't host, it was -- listen. So yeah, see, I got corrected because I looked up documentation here. So this help file or help text shows all the possible things that you can do by invoking the command. For me, I just want to stay basic, so I will just run the program like this. Listen. So listen, it wasn't host, it was listen. And then port would be 8888. So doing that, it looks like it's found my graphics card, 5070. And then I wonder if it's loaded anything. Okay, so it has loaded something, and it's about 128 megs on GPU. Super important that we keep track of that. So let's open that up by going to localhost 8088. And yeah, we have the ComfyUI interface. Now, big models like QuenImageEdit is probably not going to fit in the GPU. So let's find something that we can use to play around with. So we have QuenImageEdit, we have HiDream. Not even sure if this will even fit, but we can just explore HiDream E1 image edit. Okay. Yeah, Flux Dev. Flux Schnell is definitely something that we could run. We could run it in a quantized fashion. There's also a stable diffusion. So let's see. Let's see if we can do text to image first. And see if we can get something that can fit in VRAM. So if we tried Flux Schnell, for example, it looks like this one is FP16. I wonder if we can get a quantized version. So let's see we can find anything here. Flux Schnell, full text to image. How about this one? It's this one. Okay, so this one is also pretty big. All right, let's just try it. Let's just try and see what ComfyUI can do. Maybe ComfyUI can automatically quantize. So if we go and look at the documentation, maybe, so resources, docs, let's search for quantized. Okay. So yeah, let's ask this AI assistant. So running quantized models. Okay. It looks like I prematurely did something. Okay. Running quantized models. And let's just read the basic concepts. Models are essential building blocks for media generation workflows. They can be combined and mixed to achieve different creative effects. The word model has many different meanings. Here, it means a data file carrying information that is required for a node graph to do its work. Specifically, it's a data structure that models some function. As a verb, to model something means to represent it or provide an example. Okay. I think that right here they're referring to the AI model. So the primary example of a model data file in ComfyUI is a diffusion model. This is a large set of data that represents the complex relationships among text strings and images, making it possible to translate words into pictures or vice versa. Other examples of common models used for image generation are multimodal vision and language models such as CLIP, and upscaling models such as Real as Argan. Okay. Model files are indispensable for generative media production. Without them, workflows cannot proceed effectively. Models are not included in the ComfyUI installation, but ComfyUI can often automatically download and install missing model files. Many models can be downloaded and installed from the ComfyUI Manager window. Models can also be found at websites such as Hugging Face Co., Civit, AI.green, and GitHub.com. Okay. Using models in ComfyUI. So download and place them in the ComfyUI program directory. Within the models folder, you'll find subfolders for various types of models, such as checkpoints. The ComfyUI manager helps to automate the process of searching, downloading, installing. So maybe this is what we're trying to do. I think I'm looking at the templates and probably not the right place to start. Maybe it is the models place. Okay. But I think this is local. Let's see. So ComfyUI Manager is what we want to look for. Is it this one? Where is the ComfyUI Manager? Ooh, cool. We have logs here. Maybe should have read more documentation earlier. Okay. I'd say if we can't find it, let's just continue reading. So the ComfyUI Manager, maybe we'll get it over there. Yeah, let's look at the interface overview later. But anyway, so yeah, we just restart ComfyUI if it's running. Good. So in our workflow, we create a node appropriate to the model type, load checkpoint, load LoRa, and load VAE. In the loader node, choose the model you wish to use. Connect the loader node to other nodes in your workflow. Okay, so let's just use one of those template things. Okay, yeah, so it doesn't really tell us anything yet. It's just teaching us how to connect models. We're not interested in the training and refinement yet. I think that's just like fine tuning. So let's take a look at the ComfyUI Manager maybe. So localization, workspace areas, menu bar functions. Now, let's see, ComfyUI Manager. So ComfyUI Manager is a tool for managing custom nodes, models, and plugins. Okay, so it was right there. Okay, let's go look for that. Is it here? No, where was it? Where did, what? Let's see. Open ComfyUI Manager. Where would this be? Is it up here? Oh, do we need to download this? Let's see. Automatic download. ComfyUI desktop, ComfyUI portable. Oh, I think this might be just for the desktop, probably. Oops, what did I do with this? Okay. Let's just kind of dock it there. All right, dock it. Okay. That's fine. Manager extension. Oh, here we go. All right. ComfyUI extension. So I think this is all the ComfyUI things here. This is interesting. Okay, so we have dev mode. Locale is English. This is interesting. Okay. This is just Q button, workflow persist, workflow state, and restore on page reload. Auto save, no. Okay. Appearance, that's fine. Well, whatever. So can we search for things? Flux? No. Okay. But we can definitely load them, right? We can refresh and we could probably just download them somewhere. Okay. Okay, so let's just do it. Let's just avoid the analysis paralysis and just download everything. Okay, so I think this will just trigger download. Yep, and we'll have to like move it. So I'll just do this from the command line. So we'll drop this into VAE, this first one here. And I believe all it is just going into the models folder and then just downloading it into the right places like last time. So you just do that. Yeah, each one is going to take a while. So what I'm going to do is I'm going to download all this offline and then I'll resume the recording. So I found out what works now. It is the case that if your image generation model is too big, you can offload it to your CPU. So in this case, when I had generated using an image using FluxSnell FP8, for example, let's just do it right now with 4 steps. What's up happening is my GPU memory is saturated, and all the rest of the model goes into my CPU memory, and it really isn't that bad in terms of speed. I think this one is already cached because I already did it once before, but let's increase it to 10 steps and let's just do that again. And we'll see that the GPU memory here is now filled. And we see here that we're using, in this case, 19 gigs out of, I believe, the 32 gigs that we have. So it is the case that we are able to run bigger image generation models as long as if it's in RAM. So that's a good sign. So that's what I wanted to do. That was like the easiest thing, is just to confirm whether or not like low VRAM, with low VRAM, are we still able to generate images, especially nice ones, using just only 8 gigs VRAM, but having it be a bigger model. In this case, this FluxSnell FP8 save tensors is about, if I looked at the file size here, about 17 gigabytes. So 17 gigabytes in an 8 gig VRAM card, and it's 10 steps already produce something like this. We can do something else. So let's have ChatGPT generate us a prompt to generate an image. Let's do something. Let's generate something like a strong warrior embarking on a journey to defeat an evil sorcerer. Okay, and let's have ChatGPT make this better. I want to generate a prompt to pass into FluxSnell an image generation or text to image generation model. A text to image generation model. I want to start off with a prompt something like this. Can you help me do better? Give me your best prompt. Okay. So let's do that. let's have ChatGPT generate a prompt, and then we'll copy that and we'll put it into the image generation model. Um, not not exactly creative today, so we'll just use whatever this thing gives us. Okay, so the positive prompt here. So this is the main prompt. Dark fantasy cinematic key art. A battle-scarred warrior in weather plate and fur cloak strides across a windswept highland towards a jagged obsidian citadel where an ancient sorcerer's green witch light coils in the storm clouds. Low angle, 35mm perspective. The warrior's ruined greatsword on his back glows faintly. Ravens circle overhead. Rain and mist catch the moonlight. Dramatic rim lighting. Volumetric fog. Wow. Lightning on the horizon. Leading lines from broken standing stones, guiding the eye to the distant fortress. Gritty realism with painterly texture. Okay. Ultra detailed materials. Scratch steel, wet leather mud. Sharp focus on the warrior's silhouette. Shallow depth of field on the background. Color palette, cold blues and slate grays with toxic green accents. So is this something with ChatGPT is that it always loves the cold blues and slate grays. Epic, foreboding, heroic. Let's do warm red and energetic yellows. Or how about energetic yellow or reds and slate gray? Let's just do that. And then a negative prompt, cartoon, anime, 3D rendering, flat lighting, low detail, blurry logo, watermark, text, extra limbs, deformed hands, distorted face, oversaturated colors, plastic sheen. I like this. This is good. I want to avoid all of this stuff in the negative prompt. So let's copy that. Oops. Let's copy that here. So the clip text negative prompt. I think if we expanded that, we can paste this one here, and then go back here, and we can copy this one here. We can edit this prompt to be, I'd say, energetic yellow, or electric yellow orange, and slate grays is fine. Or slate grays with toxic green accents. So it'll be very bright. I'm not even sure what I'm getting myself into doing this, but let's do 20 steps in this case. And then CFG, let's just bump that up to 2 and keep everything else the same. Oh, wow, look, note that Flux Dev and Shell do not have any negative prompts, so CFG should be set to 1. Setting CFG to 1 means the negative prompt is ignored. Okay. The Schnell model is a distilled model that can generate a good image with only 4 steps. Oh, okay. So we gotta read the docs. So this we don't need. How do we do this? Do we just get rid of it? So negative prompt conditioning, positive, negative. Do we just do select Control B? Yeah, there we go. Okay. Control B means to deselect it. And I guess we could just run it. Prompt execute. Required input missing negative. Oh, we do need negative. Huh. Okay. Maybe this thing was not documented correctly. Okay, well, let's see what happens with just CFG1. We'll go from there. Okay, so now we're going to generate an image, 20 steps. Let's look at our resources. So we're in good shape. We have our entire GPU being used and lots of memory being used here, but we're able to still generate that image. So in VTop, you see a lot of GPU activity on GPU 0, so that's a good thing. Good to monitor memory. It's a 47 watt GPU. I find it hard to believe. I thought this would be more, but I'll take it, because if we look at ComfyUI here, we've already generated 13 steps out of 20. So we'll get our results soon, which is impressive. Less than 2 minutes. Okay, so let's see what we get. This is not bad. This is not bad. Electric, yellow, orange, green. This is not bad at all. I like it. Um, what happens if we go higher? What happens if we go for 50 steps? Did we get anything better? Did we refine the image? So let's check back. Okay, this is what 50 steps look like. I think that's really cool. Um, really good for like a cover for some novel or something like that. So awesome. We can generate images on low VRAM. That's great. So now the next thing I want to explore is image editing. So image editing. I'm not quite familiar on exactly what good ones to use, but I've had experience with quite an image edit before. I'm just not sure if we can fit it into our computer. But I don't know what the difference between these two are, but let's just see what we have here. It looks like it could fit. I mean, 19 gigabytes. That's similar to what we had before, and this is FP8. So let's try this one. Let's try to download this model, all these dependencies here, and try to edit some image. What I'm going to do is I'm going to edit a screenshot of the Netflix TV application for personal, like obvious bias. All right, so I'll do that, and then we'll go from there. All right, so we got everything we need. Okay, do we have a sample image already included? Probably not. So what's going on here? Basically, we load the models. Okay, still don't really know what this is truly. It's quite complicated, but I guess we'll have the directions here. And then if we have another image, I'm guessing here where we want to merge them together, I suppose, like kind of do two images where, like, let's say you have a picture of me and you have a picture of like some sort of box. You can probably create an image that has me carrying a box or something, and some parameters, and then I guess this is where the result's going to show up. Okay, why not? Let's just go for it. So we'll save image here. We'll save it into the desktop. WebP is fine. And then let's go and load that up here. Not here, but here. So we'll choose a file to upload. Let's go for the desktop. We'll have this image here. Okay, so this notice to avoid bad output results caused by excessively large input images. Okay, I think it means this one right here. We'll scale your image to 1024 by 104. That's quite strange. Okay. We will use the size of your first input image. This notice to avoid having input unit size too large. Okay. So I'm guessing this is okay. Here we can say this is a screenshot of the Netflix TV application. I guess we can say convert this screenshot to be using maybe a high contrast light mode theme. Probably good because this is dark here, and we can just do that conversion. 20 steps, that's fine. CFG, let's just keep it default, see what it can do, and we can tweak from there. So I'll hit run, and let's see if we can even run this thing. Let's see. So partially loaded 6 gigs. Okay, offloaded 1.69. Okay, looks like it's okay so far. Um, about 19, 21, 23, 25. Yep, we crashed. I'm not even sure if it's still recording. Okay, we are. So that didn't work out well. Um, let's look for something else. Oh, we don't even have, we had to start everything all up again. Okay, source VNV bin activate. Let's listen. Python, main.py listen. Okay, so definitely too big for us. So image editing. We can just kind of go back to here. Maybe chrono edit? No, that's video. So let's look for generation image. Image edit. Just close here. Maybe something smaller. Let's look for something smaller. Um, High Dream? Editing accuracy. How about we just FP8 here? No. High Dream. Let's do High Dream. How big are we looking? Oh, whoa. Too big. No. Let's see just like a High Dream FP8 maybe. Maybe there's this one might be smaller. No, 31 gigs. Whoa, way too big. Image edit. We already went with the chrono edit. That was like a video one, right? How about what's the difference between this one and this one? 2509 versus normal. There's OmniGen 2. Okay, so we know this one's too big. How about Flux Context Dev Image Edit? Is this big? This looks promising. This one looks very promising. Okay, let's do it. Let's download it and go. So this one goes into text encoders. Might be running out of hard drive space soon. This only has this 500 gig SSD. I already have downloaded a bunch. Okay. Next one. I keep doing that. Let's reload. Okay, one more. Diffusion models. I feel like this is very promising because it's 11 gigs. But I don't know what else is loading in the background because we've downloaded so much stuff. We probably already have those dependencies. Let's refresh again. Cool. Great. So we have something here. This looks just like the previous model. Yeah, let's just go for it. Go for it. Load image. Load image. Image is 1 WebP. Then this is the, what is it? This is the positive prompt. Okay. So positive prompt, we'll just say, okay, this is the this is a screenshot of the Netflix TV app. Edit this image to have a high contrast light theme. Or how about not high contrast, but have a light theme in contrast to this dark theme. Do not change anything else about the layout or the contents. Only change the color scheme. Okay, let's see what this gets us. 20 steps, that's good enough. I mean, it'll crash pretty fast. And here's a preview image. I'm guessing it'll update as it goes. We can just check the progress here. So it's loading Flux. Okay, so we are actually able to run this. That's great. Cool. So now we know that this model works. But is it doing anything? We'll see. Hey, this is not bad. It didn't change too much. Yeah, more or less the same. However, I would say that the focus ring probably should have maybe been different color, let's say gray. Other than that, we have more or less the same content here. Is there a way we can change the resolution of this image so that it's scaled correctly? It looks a little off to me, but maybe that's just because these are not enough steps for it to do. Okay, so let's look for size. If not, that's okay. Yeah, it's okay. I still need to learn what all this is, but we're set up correctly. Let's crank this to maybe 2. Actually, let's go 2.5 here. So classifier free guidance scale. Let's just, yeah, balances creativity and adherence to prompt. Higher values result in images more closely matching the prompt. However, too high values will negatively impact quality. So let's find a balance, and then let's crank this one up to 50 and see what we get, see if it's effective. Yeah, let's check back after we run this once more. Okay, so this turned out horrible, and I'm guessing that is because of our CFG. What happens if we crank that down to just 1 maybe and try that again? But yeah, this was not the result I wanted. This is horrible. Maybe we denoised way too much too. So let's just see. Control generate. Yeah, let's just use CFG1 and see what we get from that. This is experimenting. Well, it did a lot better now. I actually had it try to add the focus ring around here to be dark gray, but it ended up probably modifying this one up here on the home navigation bar. Otherwise, quality, it looks good. It still looks strange to me, but I think it's just the high contrast stuff. Relatively overall good job for what it is. I would totally use at least for image training, training models with classifying and things like that. It's a good augmentation tool, especially if you can do it programmatically. And I think that's what we're going to explore next time. But I just wanted to take some time today to just mess around with ComfyUI just to start out, and then probably will advance to more complicated things. But the ultimate goal here is to write automation scripts to just do stuff like this, so that when we need to do some augmentation on our Game Boy AI project, we'll have something ready to just fire and forget. So that's about it today. I hope this is really handy, and also a good look into what we can do with just an 8 GB laptop GPU. Apparently, we can do quite a bit